What's up? It's 10, reading watches are hard. 30, 40, 38, 37. Yep. Oh, it is the morning, and we are gonna learn linked lists in Java today, because they're really hard. They're not really hard, they're just, you actually have to try, and you can't just like go step by step. You have to be like, okay, understand why this interaction is working with this interaction. So we're gonna do it. We're going to take. You know what? You know what I'm gonna do? You know what? We're gonna do it by the book. Yes. This is a book that I found in my brother's room because, you know, brotherly love and sharing and stuff, so we're gonna see. Okay, maybe we won't do it by this because this is, wait, it's like, okay, so it's talking about nodes, and so, so pretty much the goal for today is learn linked lists in under an hour. And what I mean by learn linked lists is understand what's going on, because not just like I could probably memorize like how to code it, but just because I can memorize that doesn't mean, you know, I understand it. So we are not going to use the book because I changed my mind, and maybe it's best to let the book teach itself. No, I don't know, that was dumb. What I do know is we're gonna pour ourselves some more coffee, and we are gonna stay awake. Not like it's like I'm gonna fall asleep soon, because it's 10:45. Yeah. It was like 10:42. I should have been 10:42 when I said it originally. But okay. All right. So we're back in our Java example file, and we're going to do this. Just singly linked lists for now. Later on we'll learn doubly and trees and stuff, but for now we'll work with singly linked lists. Right now, my previous video of reversing a string, that should be coming up soon. So let's get a linked list implementation on in Java. Actually, yeah, here we go. Okay. Production, yes, you typically just use the stuff in the standard library. Oh, because there's a standard library, you don't have to do this. But the point is that you learn how to do it because you'll develop a further understanding of how to do it. So, what I remember from C++ is pretty much a linked list is you have a single, you have a head node, or a head link, I guess. I think that's correct. See, I don't even remember. It's been a while. So you have a linked list, and you have a link at the top that references the next object, and this link references the one after it only, because it's singly linked list. Doubly linked list would be you'd be able to traverse the list both ways. So like if I have a node at the top and it was referencing the bottom node, it would also have a top node. Oh well, I'm thinking about this. There would be next and previous, so I don't know if I should probably just write this down. But what I understand is doubly linked lists, it would be, let's say you have two nodes, so 1 and 2, and what happens is there's a pointer. There are two pointers per node, one referencing the object behind it, previous it, and one pointer referencing the one next to it, the one after it. And it's like that for everything. So you know that you've hit the end of a list when either of those is null, because let's say you have the first node in a linked list, the first link, if there's nothing, if it's the first link, the previous, ooh, yikes, the previous link is null. I think that's backwards. I think it's the next, no. Yeah, previous, because it's original. Okay. So the previous link is null because it's the first link. There's nothing before it anyway. And then it would reference the next one and the next one, next one, until it hits the end of the link list, which at the end, at the very last node in a link, the next pointer would reference null because there's nothing after the last node because it's the last one. So, knowing this, we're going to try to apply the idea to a singly linked list. So, let me start from scratch. Okay. Oh, you know what? Because I'm more familiar with C++, we're going to reference my textbook because my textbook doesn't end until like next month. So we're going to have a C++ implementation of a linked list. And here we go, pointers and linked lists. Fantasia number 3 in T minor. Woo! Tear it up! Yeah. Words. Okay. So I think I'm kind of jumping ahead of what I should be doing. Yeah, because I should probably get down like function usage in Java, but I feel like I understand it enough to be able to understand what's going on. So, you know what? This is gonna be. I can't do it from C++ because I don't know Java pointer stuff yet. It doesn't really have pointers per se. I don't think. Let's see. Okay. So I'm going to copy this off of. I'm going to copy pasta. No, I'm not going to copy pasta. I'm going to type it all out because that will help me learn what's going on. Okay. So we have a public class of example in this case because our file name is example. And class link list test. Alright, let's do it. Okay. Okay. So public integer data 1, public double data 2. Okay. Link. Oh, you know what? We can't do that because, okay, well, we can do it, but it's going to be really confusing. So, we're going to go to GitHub. I mean, not GitHub, Java. And we're going to make, oh, I can't do that either. God, okay, so link.java, and we're going to close this. We're going to, yeah, we're going to close this. Don't save. Put. And so class link public int data 1, public double data 2, public link next link link, and then the constructor link int d1 double d2 data 1 equals, okay, so constructor stuff. Cool. And then public void print link Oh, this is getting all fancy. Okay. Plus equal to 1, plus, comma, because perfectionism, data 2, this, and then that's it. So this is print link, and then we have a link list class declaration, private, link first, another constructor of public link list first is equal to null. So the link in the first link in linked list is null. Public boolean is empty. Return first is null. Public void insert d1 double d2 link is equal to new link d1 d2 link dot next link is equal to first is equal to link. And then, so just for the record, this is obviously copying. I'm not like, this isn't original at all, like, yeah. So just so you guys know this, because I don't want you guys to think I'm just rattling off a linked list implementation, easy peasy, lemon squeezy. So, this is off of Stack Overflow. Link, equal to mail, current link dot print link, okay, current link is equal to current, this one, okay, dot next, system, dot print line, and we're going to enter a new line. And there's another class called list test public static void, and this is the driver function. Link this is so bad. Okay. Insert 1.01. Is it 5 or is 5? Okay. So 2, 2, 2, 3, 3, 3. Just for the record, I'm using VI improved, yep. Whoa, what is going on? 5. Oh, right, because, obviously I'm super good with VI. List, and then while not list is empty, link, deleted link, is equal to list that deletes. So wait, I think I'm not sure if the destructor is inherent. I think I don't remember typing it because I was going pretty fast. Insert is empty link. Oh, so unless delete is just like a list out delete, not list. Unless I missed something. I did miss something. Okay, good to know. So we have insert, and why is this not working? So print, right, insert, and then after that is delete, which is public, link, delete, link, temp equals first equals first at next, link, return temp. Okay, so let's compile this. We're going to javac link.java, and I missed a semicolon because I was trying to move over. Okay. Oh, I cannot find data, cannot find symbol data to, actually let's start at the top. What? I did it twice? Oh, so line 35, which is, wait, what? Link, in insert, public void insert, D1, D2, link, equal to new link of D1 and D2, link.next, link is equal to first. That's correct. That's written correctly. Is this, did I forget, is it like C++ and you have to do a semicolon here? I don't think so, because that's a C++ thing. It shouldn't matter though, because it's a blank, it's an empty statement, right? Okay, so data 2 on line 15. Oh, okay, so I missed an A, so that's good. I don't know why this happens, it's weird. New link list, can't find symbol, new link, okay, so line 59, we're going to escape, and then put 59, GG, and we're going to put a capital because this is a capital. Okay, so now we can Java link, and the main method as what? Main method not found in class link. Class link. Oh, am I supposed to wait? It does not actually link. Object next link is actually only reference to another link. What? Class link list. Oh, this should be called link list test, and I'm just declaring. Okay, so this is. I've never run into this before. So what we're gonna do is we have, excuse the vulgar text file. What I have to go to Java, so documents, Java, and we're going to go to link. Oh, and I have to do this. Oh my goodness. Okay, so the other day, not the other day, but a while ago, I was link list test. Okay, that should work, right? The other day I was trying to do, trying to edit a law of cosines, law of sines file, and I was getting so fed up because what happened was I had the link list file open in Atom, and I was editing it, and I was trying to fix it, trying to make it work correctly. And what happened was I had to rename it because I wanted it to be organized correctly in my GitHub folder. So I changed it to like law of cosines and sines instead of just law of cosines because I wanted to mesh the two together, right? And what happened was when I would save the file, okay, so it was open in Atom, and I deleted it. Oh no, it was open in Atom, I renamed it, and every time I saved it, it would save as another file. So when I would try to debug, and I would go through the file, and I would recompile it, and run it, it would always have the same bug. So I was like, what the heck, this logic is working correctly, I don't know why it's not working. And so what ended up happening was, I was like, let me see, the file names. So every time I would rerun it, every time I'd recompile it and run it, it would compile the old file while the new file in Atom was saved correctly. So it's like, it's this weird thing that I went through where I spent like an hour trying to figure out why the logic wasn't working correctly. When it was working correctly, it was just that I was recompiling and running the wrong file. So that's why we have to be very careful in what we do. So, moral of the story, don't be dumb. So link, Java, link list test. Okay, so Java linked list test. Okay. Okay, so this works correctly. So thank you, Aaron Ferguson, for your linked list implementation, and I will add methods to. I'll try to understand this. So enhancements to this implementation include making it a double linked list. Might as well just put it up. Linked list class already provided in Java util. Okay, but I'm trying to learn how to do it because why not? That's something that you should know. And implementation include making a double linked list. Okay, like I said before, insert, delete from the middle or end. Okay, so you're just hooking up addresses in a certain way, and you're deleting things. Okay. And by adding get and sort methods as well. Okay. Man, I remember I was doing this. My brother's also a programmer, also a hacker. The nice hacking, not like the malicious hacking. And he was helping me understand linked lists, and we were trying to discuss pointers. And this was like, I think, a year ago. So a year ago, I still didn't understand pretty much how pointers worked, which is pointers are just variables that hold addresses that point to objects that those objects can then have another pointer that point to another thing. So like when I would try to link up other, oh my goodness, this video is so long already. Whenever I tried to link lists back together, link pointers back together, what would happen is I would reference the object instead of the address. So what would happen is I would reference this random space in memory, which would get me pretty much a segfault, and I'd be like, what the heck is going on? And he was like, oh no, it's this, this, and this. And it didn't make sense at the time still, so now it's better than it was before, but still not entirely correct. So we're gonna learn. So let's... Cool, okay, so I'm gonna do something real quick. Actually, I will do that in a second. Actually, I'll do it right now. 32, guys, what's 32 plus 57? 32 and 7, 89? Let me check. Not like with a calculator, but let me check if that's right. 57 is correct. 57 and 32 is 89. Yeah, that's correct. Okay. 89 minutes. And this is first string. Alright, so the next video is up, and we're going to get back to linked list stuff because that's fun. I need to add this. Add to Java. Okay. I should probably turn off my music because it is very distracting. So we're gonna do that. Alright, so we don't need this no more. Alright. So, one second. Let me, give me a sec. Back at it again with the linked lists. So, let's understand what's going on here. So, we have a driver file, or driver function, application, no, driver function. And our file is called linked list test, and in it we have our main function. Oh, and I've been declaring that wrong this whole time, and no one told me. Because it's a, oh man, okay. I feel, that's really weird. Why does that work? I feel like, aren't brackets, okay, so I see here, I used to declare it, string args, and then the brackets, But the brackets, I feel like the brackets are reserved characters, so you shouldn't be able to declare them in... Oh, but arrays, right. But it's not an array. Okay, whatever. Okay, so lesson learned. It's not string args brackets, it's string brackets args. Okay. Lesson learned. Okay. Anyway, back to linked lists. So we have a link declaration, which is also, it's similar to a node declaration. But link, I think this makes more sense to me at least, having the link declaration, having it be called a link, because it's not like a node, it's not a node list, it's a link list. So we're going to use it like this. So in our class called link, we have a public integer and a public double, so these are pretty much just the datas that you can change, and then you have a link referencing itself called next link. So the constructor is, you have your link, so if you were to declare in your main function link parameters, and then you'd have your integer and your double, which is seen here. Oh, that's insert. Oh, wait a second. Insert. Oh yeah, it's doing the constructor here. That's what's happening. Okay. So okay, so that works fine. So you have your link, and this is just for use of insert, and then you're using insert to insert into the linked list itself. Ah, man, this is dense stuff, man. Or nah. So you have your link list. We're going to reference this one. So you're declaring a public constructor of a link, of the class link, and you're declaring that your data, this should probably be private. It doesn't matter. Okay, so you have your datas, and you're setting it equal to the parameters, and you're setting the data in the link class definition to the data that you pipe to it, right? And then when you print it, you're just printing out your datas, your data 1, data 2, so whatever the object has. And then in linked list, we have a private link declaration named first, right here on 23. And then on 25, we have linked list, public linked list. It's the constructor of a linked list itself. And you're setting the first link, the first link to null. So then you can check your linked list with a public member function that returns a boolean, and it asks if it's empty. So return when you so on 30, when you return your first so you're returning the statement first is equivalent to null, which you're saying so it's an and so if first is equal to null, so if the boolean value of first is equal to null, it will return true, because the first node in your linked list is null. So you're asking, is this empty, as determined by the function name, is empty. So it'd be something like link.isEmpty. Where is it? There you go. If so, link.isEmpty, this returns a bool, and it determines whether to go into this while loop and to do all this stuff. So that's isEmpty. So isEmpty is a member function, a public member function that returns a boolean of whether the first link is null or not. So let's say this the first link was something and it's not null, it's not equal to null, which means it would return false, which would mean in the member function down here, in the main function, sorry, so while not is empty. So while this is full, do whatever is in here. Okay, cool. So back to linked list is empty. So void 33. Public void. We have a public member function that doesn't return anything called insert, which takes in parameters of an integer and a double. Well, that is exactly what a link has as parameters. So what we're doing here on 34 is we are declaring and initializing a link class, link object named link, and we're making a new one, and we're constructing it with whatever the info here is. So for D1, whatever the parameter is for this, you put it in for here, and whatever it is for this double, you put in for this. And then we're taking the link dot next link is equal to first. Wait a second, did I miss another thing? Oh my goodness, please. Next link. First dot next link. Wait a second. Is empty, insert, delete, print. Okay. So we have link. It would be member function of this though. Link. Oh, I am. Okay. I'm sorry. This is. Because it works, right? Okay. Right. Link. Next link. What I don't understand currently is in the public member function of insert, you have this, you're declaring a new thing, and then you're taking link.nextLink. Something. Oh, right. Okay. Okay. Public link, next link. Wait. Yeah. It's just a member function, right? Okay, so you're referencing the data inside the object. Okay. Man, this is how learning is so hard, because you gotta understand and go back and look at stuff. Okay. So 33. You have a public function that doesn't return anything called insert. You're declaring a link object named link, and you're setting it equal to a new. You're making a new your dynamic memory, dynamic area in memory for this new declaration of a link that's constructed with the parameters that you give it. And then you're setting the link, this link right here, that you declare in your insert. You're making a temporary link, and you're setting the next link to the link in the link list. So you're connecting them. And then you're setting first equal, because first is a link, first is a little node, and you're setting equal to link. So you're connecting the new insert. So you have your head link, and what's happening is when you call insert, you're creating a new temporary link. I should probably use my whiteboard. Whatever. You're creating a new temporary link. So you have your head and you have your temporary link. And what you're doing with your temporary is you're initializing all the data inside this object link, and you're setting the next link of your temporary object to your head link, and you're setting the first. So you're setting your first object. Whoa! You're setting your first link right to the temporary, so that this is a new. So it's linked together. So. Okay. And then you have member function that returns a link, and it's delete called. So you have a member function that returns a link called delete, and so you're declaring a new link object named temp is equal to your first, whatever your first is up here, and you're setting first is equal to first.nextLink. And you're returning the temporary link. First, so temp is equal to first. First is equal to next. Oh, okay, so you're deleting whatever's in front. Whatever is. Let's write this out. Okay. Okay. You know what we're gonna do? We're gonna use Paint because I'm not gonna set up my whiteboard ATM. Oh, right. Okay. This should probably be main. Okay. So what's happening is, let's take. So what's happening here is you are taking. Okay, so on delete. So you have a linked list here. Wow, okay, we're not going to use that. We're going to use shapes. So we have linked list here. Okay. And you have your first. Okay, that doesn't matter. Okay, so what's happening with insert right here? Here. There we go. Oh no, it's not doing the thing. Oh man, I should probably set up for this better. So you have your inserts, and what's happening with insert is you're declaring a new link. Let's make it this color. And what's happening is when you set your new link, you're initializing it with this data stuff. So 1 and 2, let's just say this is your datas. That's part of your temporary link. Wow, okay, that is professional looking. And what's happening is you're setting the next link, so link.nextLink, next link equal to first. Wow, this is not going very well. This is really great. Okay, so set your new link equal your next link of your temporary here to first, to the first link, right? Okay. And then you're setting first equal to the link. Setting first. So wait. First. And then the next link of this. Wow, this is not going very well. How would I do this better? Let's use our okay, so attempt number 2 with illustrating what's going on. So you have your linked list, and in linked list you have a private link called first. So this is first. And what's happening in insert is you're declaring, so this will be insert int and then a double. What's happening is you're declaring a link, and there's data's in here, right? Okay. Yeah, because so these are just null D1 and D2s, right? So insert, you are declaring a new link called link, and it has in it, let's say for the sake of the example, wow, this is so bad. Okay, link, and in it you have 1 and 1.01 as a double, and you're setting the link, the next link of this this new link right here. So next link to first, to the head, right? So first link, and you're setting first equal to the whole object link. Oh man, this is the stuff that I definitely thought was very difficult to understand. So this should be about what's going on. So you have your linked list on the left, and what's happening is this linked list is being constructed with null. Okay. So you're taking this new null. What's happening is you're declaring a new link, and you're constructing it with whatever the parameters are that you declared it with, that you initialized it with. And you're setting the new link that you just made, that the next link equal to your first. So you're setting this over here over to that. Wow, this is terrible. And what's happening is, essentially what's happening is, you're declaring a new link, you're filling with data, and you're setting the new link's next link to the head. And then to the head link, right? Okay, and then you're setting that link's, the whole link to the object of your new link. Wow, this sounds really complex, but it's really not that bad. Okay, that makes sense to me. I think. Okay, so then with delete, because we're going to skip. Oh, I can go pick up my diploma, guys! Yeah! Okay, so you have public. We're gonna move on because that makes sense to me now, kinda. I need to think about it. I think I just need to let it absorb into my brain, and then I should get it. Okay. So, on line 39, we have a public member function of the class linkList, and it returns a link called, and the member function is called delete. So what happens is you're declaring a new link called temp, which is equal to the first link, and then you're setting the first equal to first link, and you're returning temp. So when you, so if I say something dot list linked list dot delete, while it's not empty, link deleted, it should print out the deleted link. So you're printing the deleted link. Okay. So temp is equal to first, and you're setting, so you're connecting. So what's happening is you have a temp link dot, yeah. Okay. So you have a temp set equal to first, and your first is equal to your first next link for your first's next link, and then you're returning temp. So what are you returning? You're returning the deleted link, and you're just reconnecting the list. Okay. So then print list current link is equal to first. You're printing the whole list. So while current link is not at the end of the list, which is show designated words, which is represented by null. While you're not at the end of the list, print the current link, which starts at the very beginning of the list, and then you're setting the current links. The current link is equal to the next link. Okay, that makes sense. And then you're printing out a new line. Okay, and then in your linked list test, you're making a linked list. Linked list object called list, and you're making a new one of it. and then you have list, you're inserting this data, and this data, and this data, and this data, and that data. Then you're printing the list, and then while the link is not empty, you're going to delete each link by link. And you're going to print out the deleted link, as shown on here, and then you're printing a new line, and then it should print out an empty list here, because this is deleting this 68 to 73 is deleting everything in the list. So when you print out the list itself at the end, it should be empty. Okay. So we're going to try to recreate this. Split right. So we're going to save this as Java linked list test. Linked. No, that's really confusing. David's test. David's link test. This test. Whatever. Okay. So we're going to put all the stuffs. Date is the 15th of August. And the description is make a linked list implementation. Okay. So we have a class with a link, and in this class we have a public integer called data1, and we have a public double. Let's switch it up. Let's do the double first and the integer next. Data2, and in the link itself, in the link object, the class of links, we have a public link, so it's referencing itself, called next link. I believe that is it. Well, you know what? We'll just do this, because why not? Right, okay. So then you have your constructor, which should be a public link, and it is composed of your double, and you're making temporary variables to set them to you. So int d2. And holy shit, this is a long video, unless I'm doing something weird. Whatever. I think it's just because this is a difficult concept to understand. So you have a constructor, and we're setting the datas that's in the link, which are here, this and this, equal to the double, which is d1, and equal to the other, which is d2. And that's it. Okay. So then we have print, which is a void, right, because you're not returning anything. Print the link, just the link, right? Okay. And we're going to print, we're going to use parentheses plus data1, which should be the double, right? Plus a comma, plus data2, which is the integer, plus the closing parenthesis, and that should be it. Okay. Why is this different? Oh, because it just looks lopsided. Okay. So then we have our class called linked list, and in it we need linked list is empty. So wait, we're gonna so private. We have a private link called first. And then we have is empty. I'm trying really hard not to cheat. This is tough. The constructor of the linked list, right? And you're setting you're initializing the first link in your linked list equal to null. and then we have a public boolean called isEmpty. And in isEmpty, we're returning if the first link is equivalent to null. And that should return a bool, right? Okay. So then insert, right? Okay. Okay. So in insert, we are returning a link. We're not returning anything. Wait, why? Why? Oh, because you're just declaring on new things. Okay. So public void insert, which takes in the double first, right? Because it's the first double. And then bool integer, right? Crap. And what you're doing... gotta cheat. Okay, so insert. You're declaring a new link called, let's just say David link, so that we can try to understand it better. Is equal to a new declaration, a dynamic declaration of the new link, and we're constructing a new link with D1 and D2. I don't know what happens. Okay. And what's happening is, the way I think it works is when you insert, you're connecting the two, right? Because we just learned this, right? We just learned this. So my link of the, so this is a new link declaration, which means it has a new next link. So the object David link that we just made of the next link should be equal to first dot, no. The next link should be equal to the first, just the first, right? Just the object? I believe that's correct. Oh, that's not what I wanted. Yeah, cool, okay. So first, because you are setting the new link, the new link that you just created, then you're setting that new link's next link, right? Yeah, to the first, the head of your link list. Okay, and then you're setting first equal to the new link, which is David link, right? Should be correct. Void insert, right? First is equal to the new link, right? Okay. And then you have a public, and you're returning a link, I believe, of delete. So you have to return something, and so that means you're making a new link called temp is equal to first, right? Because you're referencing the first link, I think, yeah, okay. And then you're setting the temp next link to first, because you're trying to get rid of first. And then you're setting, so wait. Temp, your temporary link's next link. Oh, because you're not handling the head node itself, because that's dangerous. So, because you might lose the following links if you just manipulate the link itself. So next link is equal to first, and you should set temp equal, no, first equal to temp. Whoa, 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 I am very wrong. What did I do wrong? That next link, and then you're returning temp. So let's try to rehash what happens here. So public link delete. You're returning a link of first. Okay. So you have a new link called temp. You're setting it equal to the head node. The head node. Then you're setting the head node equal to the head node's next link. So you're setting the node itself to the next link. And then you're returning the deleted link itself. Okay. Alright, so that should be good. And then print list. Let void print list. Shouldn't have any parameters, right? Yep. So we're declaring a link called current is equal to first. Yes. Okay. And we're going to print out the list. So list, David's list. And then we're going to say while current is not equal to null. Is that correct? Please. Oh, I got it. Okay. So right here on 48, current link is not equal to null, right? And that's what I did. Okay. We're going to print out we're going to print out the current link that we're at. So current, we're going to print out current itself, right? Because that doesn't seem right. Okay, so think about it. We are in our linked list class, and we're going to print the whole list, right? So we're going to declare a link called current is equal to first because you don't want to handle the head node, first node itself. We're going to print out just it's a formatting thing here, saying this is the list. So while your current is not at the end of the list, print out the current. Print out whatever you're at, wherever index you're at on the list. So you're going to print out current itself, I think. Because what I want to do is I want to do print current.data1.data2 because the currents are public. But I don't know if that's correct. So let's look. Oh. Right, because there's a member function for printing out a link. Okay. So I had the right idea, just not the right implementation. Right, not the right. Yeah, I guess implementation. So current.print link. This is what learning's for. And then we're going to set the current is equal to current.next link. And then delete. Okay, is this correct? Right, because that's, and then, no, that doesn't seem right. Why is that not right? Okay. So while we have our current, oh my god, is this a 2-hour video? Oh my god, this is gonna be a 2-hour video. Scheiße. Okay, it's okay. We're learning stuff. This is what we're doing. This is why we're here. Trying to get better at using Java. So while current is not equal to null, so while the link that you made, because first is private, you're not supposed to access privates because that's bad. You're trying to hide the data of the private in your implementation. So while you're not at the end of the list, print your current link, right? Which should print out the parenthetical words and the data. So parentheses data of 1, comma data 2, and parentheses. So you're going to print that link, and what you need to do after that is get to the next link, right? But you're just printing it, so you don't have to delete it yet. Okay. So print the link, and then you're setting the current to the next link, and this doesn't seem right. You want to print out. Do you want to print out a new line yet? No, it doesn't matter. So what's happening is you're referencing next link. So you're printing this, and then you want to set. Okay, let's just see. Let's make our David's list test public class this static void name string brackets args, and we're going to make a linked list, or yeah, just linked list, right? Okay, linked list it's a new list is equal to a new list. Is it just that? Cool, I did it right. Okay. And then we're going to insert datas. So 1.01 and 1. Actually, let's make it fun. So it's not fun. Cool. And then 37, because that's, legit. 2 legit quit, and then we're going to insert another double called this, and an integer that's this. And then we're going to insert another element, just three elements, called that, because it's close enough to, poop. And then we're just going to do 9009 because it's over 9,000. And so when you insert something, it's not going to print anything, so you want to link.printlist, and we're going to see if this works. Wow, this is actually really tough. Okay, so Java C, David link, I think that's what it was. David list test, David's list test, Java. New list, link list. I was close. Link list. '65 can't find symbol of list, variable link in the class David's list test. But I'm declaring because what you're doing here is you're declaring a new linked list with the first node being null, and then you're inserting. So why is this not able to be found? Linked list, called list is equal to new linked list. Why is that not working? Linked list, yeah, new linked list is equal to new linked list. Why would this not work? So you can't find the symbol because 65. Wait, 65 link. Oh! Okay, that's dumb. Okay, so what happened was I called link, right? This is what the original issue was. I was calling for a link, but there's no thing called link to be referenced. There's no link list called link to be printed because it doesn't exist. Because in this scope, this does not exist. This itself does not exist. So, okay, so lesson learned. Now it should work. So, okay, and then at the end of print list, I want to I want to print a new line. So system. Okay, so this should output a new line after it's done, right? Okay. So we have. Okay, so now what do we need? We have our print list, and this is working correctly, I think. Let's make sure. Boop. Insert. Delete, print, false not equal null, print out the current links, print link, and then you're setting current. Oh, did I get that right? I got it right. Okay, so you're setting the current to current next link because you want to look at the next link over, and then you want to print a new line. Cool. So now, wait, is that it? Oh, that's it. Okay. So now what I want to do is I want to delete whatever's in the linked list that I made. So we're going to while not list that is empty, right? Because that is what it's called. We're going to, okay. Oh man, this is tough. It's not tough. It's not tough at all. Just tedious. So, while the link is not empty, we're going to print out the link. Oh, we're going to make a new link called deleted link. And we're going to set it equal to first. I believe. Ooh, is that it? Please tell me that's it. Insert, and then you're printing, and then so okay. So link setting the new link equal to list.delete. Why? Because we're setting deleted link. Okay, because we don't want to mess with first, because that's stupid, and we're not even in the right class to use it. So link, deleted link is equal to list.delete, because delete returns a link of whatever deleting, right? Okay. So, hey, what's up? And you're going to hear me talking to myself, okay? Okay. Okay. So, while the link is not while the list is not empty, make a new link called deleted link. That is the deleted link, and you're going to put deleted plus deleted link dot print link. And then you're going to set you have to move it over somehow. So what am I doing wrong? List.delete is deleting the first, right? Okay. Print deleted. Deleted link, print link, okay. And then you're setting a new line. Wait, and then that's it? System.out.print. Oh wait, I don't have to do that because I do it here. Okay. So, while this is not empty, make a new link equal to the returned link of the link that you're deleting in list, and then you're printing out what you deleted. So oh, and that should be it, because you're deleting, so you have this new link and you're printing the deleted link, and because delete itself moves over the list's first node to the next one, this should be it. And then at the bottom we want to print the list again, which should be empty. Okay, so let's see. Void type not allowed here. What? Error void type not allowed here. Why is that a void type? Is it because this has to be on a separate line? Okay, let's try it. To check on the same line, and then you print new line of this afterwards. So void type not allowed here. Why? Because delete link, print link, it's... So wait, really? You have to do all this stuff? And then you print out the link itself? No, that should come after, because this is on the same line, right? So the same line, it'll print out the deleted link, and then print out a new line. Okay. Okay, so we got that down. But do I understand it? Okay, so... Oh man, this is such a long video. It's okay. We're learning stuff, so that's good. This makes sense, I guess, because let's just start up at the top. So we did it. Yay. So you have a class called link. In this link class, we have three data members. Three members with a double, an integer, and a link that references the next link. And in the link constructor, we have a link constructor of the two data members for whatever the parameters are that you pass it. And then a print link function for links to show whatever the data is. Okay. And then in linked list, we have a private link called first, and we construct the linked list's first link to null to make sure it's empty. And then we have a member function that returns a bool to check if it's empty, for the sake of the main function where you delete everything that's in it, inserted into it, using this insert function, which takes in two parameters. It creates a new link, and it constructs the new link with whatever the parameters are with the constructor right here. And then you're setting this link, this new link, this next link to the first object, to the first link object, okay, which is null. And then you're setting first equal to this first object equal to the new link. Oh. Yeah, that makes sense, because, oh, that's cute. Okay, so you're setting the next link equal to null, and then you're setting the first equal to the link itself so that it has these, the data members copied. And then for delete, we're returning a link of whatever we're deleting. We're setting it equal to temp. We're setting temp equal to the first link, which should be whatever I'm just going to say frontmost, because that's what makes sense to me. Frontmost link, which has data in it, assuming that the linked list is not already empty. And then we're setting the first we're setting the first links equal to its next link, and we're returning temp. So list.delete. Oh yeah, because we're getting rid of that. So we're just showing whatever it is that we're deleting, right? Okay. And we're having print list, which just goes through the list. So we're creating a new link called current, which we'll think of it as the index that we're at, index of the link list that we're at. We're printing a formatted line that says this is the list, and then while the current new link that we just made is not equal to null, because nulls represent the end of a list, we are going to print the current link or node and whatever the data is inside it, because that's what's defined in print link, which is up here. So it prints out whatever is inside of the data, inside the link, whatever the data is inside the link. And then we're setting the current link to its referencing itself's next link, which effectively moves over the index of the link list over 1 until, and we're doing this until we get to the end of the list up here. And then we're just formatting it by printing a new line. So in the list test, we have our main function, and we're declaring a new linked list called list, and we're making a new one, a dynamic linked list, and we're constructing it with a null, because that is what the constructor does. So you're setting the private link named first to null, okay, and then we're inserting into it this data, because it's a double and then an integer, into the link. So when we insert, what we're doing is we are making a new link. We're setting this new temporary link to the first, which is null, because we're making the next link null, and we're setting first equal to this new link. So what's kind of funny to me is I think that this should go first. You should set, actually what happens if we do this first? Because you're setting first equal to the new link, right? And you're setting the next link. Oh, you can't, because then you're referencing this, which happens this. So this has to come first. Because first in this, so if it's written like this, with 36 being first, this is still null. So first is equal to null. Is equal to null. In this, so what's happening here is you're initializing, you're assigning the new link's next link to null, essentially. This is what this is doing, because up here, first is declared as null. In the case of this is the first insert. Okay. So what's happening is you're setting the next link equal to null, or on the second insert, first insert, second insert, second, third, nth insert. We're setting first equal to the previous, equal to the list, the link that holds the entire list. So link that holds the entire list. I don't know why I multi-line commented that, because it's on a single line, but whatever. And then we're setting first equal to the new link. So okay, so first link. So we're just inserting. So if we have a list, okay, we have a list, and in it we have null. Okay, so we have null. What happens when you insert is we're creating a new node, we're initializing with data, and we're setting this new link's next node to nothing. because that indicates the end of the list. And then we're setting the first link equal to the new link so that we can keep inserting into the next link and the next link. So it's like node, link, sorry, I should stay consistent. We're initializing a new link, and we're putting it into the next one, and then we're scooting it over. And then now we're working with this one, which has data in it. So first insert, it's null that you're inserting into. And then second link, we have an actual link object with data in it, and you're declaring the next link equal to this new first link. Wow, this is really difficult to explain, but this makes sense. You're just you're inserting and inserting into the next link, and then it references until you hit the null, which is the end of list. God, okay. And then here you're printing the list. Here, while the list is not empty, designated by the bang, this is called a bang, the exclamation point. Exclamation is equal to bang or negate or not. So while the list is not empty, do this stuff, which is you're declaring a new link and you're setting equal to the whatever link that you're deleting. Then you're printing out the deleted link, so designated here, and then you're putting a new line, and you're doing this until it's deleted, right? Yeah, so it's saying deleted, right? And then when you print out the list again, there should be nothing in it anymore. We did it! This is like 2.5 hours. Woohoo! Next time on learning stuff. I'll catch you next time.